Hello everyone, Alex Chepurnoy, also known as Kushti, Ergo core developers here, and I'm going to present my talk, which is named Ergo, a platform for cryptographic applications. Today I will talk about cryptographic applications doable on top of Ergo. So how can we do cryptographic protocols as applications on top of the core protocol, and how Ergo can be compared with other known blockchains in regards with that aspect, in regards with being a platform for building cryptographic applications. So it's not about DeFi in general, for example, in this case, but those cryptographic protocols can be used as building blocks in DeFi applications as well, for sure. All right, so let's start with some history as usually. So before Ergo, we had Bitcoin in the first place. Since 2010, Bitcoin introduced a few instructions in its script language to check a signature for transaction bytes. Well formed in some specific way. For checking a multi-signature, for calculating a cryptographic hash. Right, signature in these instructions is ECDSA signature, which has some drawbacks. Schnorr signature, scheme support is coming. Schnorr is simpler. It has probable security, and also it allows for cryptographic protocols, off-chain cryptographic protocols to be built on top of on-chain Schnorr signatures. All right, so Bitcoin had a little bit. But to add some new features, you need to fork Bitcoin. So a lot of Bitcoin forks appeared in regards with adding some cryptographic features. Most of privacy coins still forks of Bitcoin, and usually those forks are just adding some cryptography to the Bitcoin protocol. For example, Zcash, adding new mint and pour instructions, and so on, so on. Then we are having Ethereum since 2015, and EVM chains later. Here, we have some instructions and precompiled contracts, and we have more than in Bitcoin usually. Some examples will be shown later. But usually we can talk that there is support for checking a signature, not just for transaction bytes, but also an arbitrary message. And in case of Ethereum, there is also support for some pairing operations to support snarks efficiently. All right. So now what's Ergo introduced? Ergo is introducing a native support for composable Sigma protocols, so a class of efficient cryptographic protocols which are composable, which are having a standard way to be introduced in non-interactive form, to be converted into a signature. Right, so in simplest case, simplest Sigma protocol is a Schnorr identification protocol in case of signature. So in case of blockchain, we are working with non-interactive protocols, so signatures. Simply, this is about Schnorr signature then. Right, so Ergo has support for Schnorr signatures since day one. And more, there is support for ring and threshold signatures out of box. And there is also efficient support for many cryptographic protocols. So some of them I'm going to uncover during the talk. All right, so let's start with Schnorr signature. Basically, it's what Bitcoin going to have. Right, and Ergo's Schnorr signature is pretty close to known standards, but there are certain differences also, as well as in Bitcoin. But in general, it's close and it's pretty secure. And specification will be published someday for the Ergo signature scheme. All right, so like Bitcoin's Schnorr signature, Ergos is also allowing for some protocols well known before or discovered by Bitcoin community, such as music. There is possibility to do adapter signatures and private swaps based on them. There was a demo of private swap between Ergo and Bitcoin Cash made back in May or June 2020, so like 1 year and a half ago. Here, there is a hope that with Schnorr signature coming into Bitcoin, we will have a lot of protocols while working in the real world, so implementations, not just papers. And Ergo is on the same level as Bitcoin, so hopefully all those protocols will be supported. Ergo is using also the same elliptic curve as Bitcoin, so hopefully changes would be minimal for software to be developed on Bitcoin. Ethereum is not going to catch up here. So Ethereum is using ACDSA signature and going into some completely different direction, I guess. All right. Then the first application appeared on the Ergo blockchain is Ergo Mixer. And the basic idea, the basic scheme behind the mixer was discovered back in 2018. So in 2020, a paper was published. All right, so a mixer is a basic tool to restore fungibility of digital nodes. It's useful in many cases, mostly to hide sender privacy, right? Ergo scheme, after some modifications, still this basic scheme, so it was called zero join. And it's based on ring signatures and a proof of knowledge for a Diffie-Hellman tuple. So it's a little bit more complex protocol than Schnorr's. And this protocol is actually about proving that two group elements are having the same secret exponent, against two possibly different generators. There is a paper published and also available online on ePrint server of IACR, International Association for Cryptology Research. A lot of details there, how to avoid privacy leaks caused by fees, for example, and so on. What other schemes are missing often? Covered in this paper in a very detailed way. Enjoy. There are a few implementations for zero join, and currently active one is Ergo Mixer, desktop software. Some wallets are going to support this scheme also. And comparing with other blockchains, for Bitcoin, we don't have on-chain mixing, so you need to use some trusted servers, and in best case, so you just trust your privacy, right? In the worst case, you also trust. So you put trust in money, right? So your funds can be stolen by servers, and there were actual case for that. So a lot of issues if you are using trusted services, there is some research in the Bitcoin community how to do mixing without trusted services, but still no any concrete implementation around. All right, so in case of Ethereum, there are some efficient privacy tools, but they're all trusted setup based, because using ZK snarks, there are some schemes, but they are inefficient and sometimes leaking privacy still because of fees to be paid and so on. So a lot of issues here. So in case of Ergo, the Ergo Mixer is efficient, so it's on-chain, no need to use trusted service, and even for on-chain contract, trust assumptions are minimal, so no trusted setup, no complex math. So yeah, actually pretty simple math and very plausible cryptographic assumptions. All right, next I'm going to talk about stealth addresses. So it's a tool to hide recipient privacy, and in general, the idea is as follows. So you are visiting, for example, a shop's website, you are getting some hint there, right? So from the hint, you can derive payment address, one-time payment address, right? So you are paying to this address, but only the shop can uncover the link between the hint and the address, right? So only a shop knows that this payment belongs to it, and only the shop can spend it. All right, so contracts are actually very simple, available on the Ergo forum. No formal paper, but yeah, actually this very simple stuff. And I don't know about stealth addresses for Bitcoin and Ethereum. So they're available in privacy coins, usually such as Monero and so on. And so in Ergo, you have a stealth address contract, and it's efficient. All right. Next use case is about ring and threshold signatures. So as I said before, there is native support in Ergo, and even more complex scheme are supported. So you can state that to spend a coin, ring and threshold signatures, so both of them are needed, right? Or maybe a ring or another ring, right? Which is a ring of rings, or ring or threshold signature, and so on. So ring signature is one out of n signature. So it's when possible ring of signers, maybe like 10 of them, right? And that's one of them signed a transaction, but zero knowledge is preserved here, so you don't know who is that guy. So the same is for threshold signatures, but this is about k out of n condition, right? So 3 out of 10, for example. So that out of 10 known signers, 3 signed a transaction, but you don't know who are those 3 guys from observing the signature. All right, so there are implementations already available around. So there is support for complex signature schemes in the Node API, and there is also a desktop application called Zero Knowledge Treasury for joint control. And it's used by some DAOs already, such as Dark Fund Zero Fund, which is providing grants for privacy preserving applications on top of Ergo. So again, comparing with Bitcoin and Ethereum, no known implementation. So for Ethereum, you can do maybe some limited things, but it would be very costly actually. I never heard about something in production, so in the real world. So in Ergo, it's available, and it's pretty efficient, and up to 255 signers supported for one condition. My memory serves me well. So for threshold signatures, for example, right? So for one threshold signature, you can use a ring up to 255 possible signers. All right. Next is about doing cryptographic things in a contract. So you can calculate a hash, right? It's the basic thing. But what if you want to check a signature for arbitrary message in a contract? So this can be done actually very trivially in an Ergo contract. So there is an example available in SUSE breach implementation. So soon we will publish a forum post with just this contract extracted. And so in Bitcoin, there is no such possibility to check a signature for arbitrary message. So in Ethereum, it could be done and actually efficient, for ECDSA signature, thanks to EC recover method available. And in Ergo, Schnorr signature can be checked efficiently. All right. So all those schemes mentioned before are implemented. So for stealth addresses, there is implementation done just a few days ago during Ergo Hack 3, and so support is now going into Ergo Mixer. Yeah, I'm talking about very real stuff, but there are more schemes around still not implemented, and I'm pretty sure more are going to appear. So there is a new mixing scheme just appeared around and now under review. It's called yet another mixing protocol, so it's a simplified mixing scheme. And yeah, there are some advantages over the basic zero join scheme, and yeah, it's even simpler at the same time. And so a few years ago, there was a hype about Merkleized abstract syntax trees in the Bitcoin community. And so there is support for more powerful so Merkleized finite state machines, so they're allowing for cycles, unlike Merkleized abstract syntax trees, for example. And the contract is around since 2018, so it's done not in Ergo script, but Ergo driven, so kind of Ergo assembly language. And yeah, maybe soon I will do an ErgoScript version and publish. So the team will do that. Yeah, so we will publish an ErgoScript version on the forum. So undoubtedly more things to come. So you're welcome to come and build on Ergo. And thanks for your attention. And well, from this talk, I hope you now have a good understanding what's actually done and what's possible. And still, well, we don't quite know the limits, so please come and try to find them well with us. Again, thanks for your attention, and have a great summit. Bye.